Another method of updating the beam section properties of our 1D beam elements is by extracting section cuts from a solid. This can be done through using the Section Property tool. First, let's isolate the beam sections we want to update and hide the fuselage mesh. In this case, we will be updating the T-shaped beam elements. Looking through the part tree of the GA Aircraft CAD, several stringer geometries are listed that occupy the same location as the T-shaped beam elements. These new stringers are not attached or associated with the T-shaped beam elements in any way, but we can use the geometry of these new stringers to update the cross-sectional area of our 1D beam elements. Here, we have a section of the new stringer that contains a doubler. Opening the Properties browser, we can see two material properties listed. Property 5 is associated with the doubler, and Property 4 is associated with the new stringer. These material properties are important to note as this new cross-sectional area is created. Now, we will go to the Mesh ribbon and select the Section Property tool, which we will use to update our beam section properties. With the 1D window selected, we will select all of the 1D beam elements. In the following window, we will change our selection to Solids and select our new stringer and doubler. Now, we can select the location in which the cross-sectional area will be measured. We will select somewhere in the middle of the doubler, and a red outline will show the cross-sectional area that is currently selected. By pressing the arrow, this cross-sectional area is applied across all of the beam elements, even though the doubler does not extend across the entire stringer. This cross-sectional area is now assigned to the beam elements instead of the T-shaped cross-sectional area. The Section Property tool automatically calculates the homogenized material properties for the homogenized section. This can be seen in the Properties browser by looking at the newly added material property, which is titled AutoProp 5. Finally, by changing the viewing settings, we can see a series of solids that appear in the location of the beam elements. These solids represent the stringer and doubler cross-section that we have added.